So hello everyone, I hope you can hear me okay. It's 12 p.m. and I think we can wait 1 or 2 minutes more just to get everybody in. And today's topic is related to the regulation of GMOs and CRISPR. And basically, before we start, I would like to extend the topic because probably because everybody knows what GMO and CRISPR are. So this is the title of the topic, but today we are going to speak about mostly about conventional approaches to genetic modification and a new set of techniques, and CRISPR is one of them, and there are no universal or no universal understanding what kind of techniques are included in new techniques. So, and there is no even common definition. So it can be all kind of techniques related to genome editing, or sometimes there are different approaches that's define these techniques under the term NGT, new genomic techniques, which is also very, sometimes can be very unclear. And sometimes even grafting is included in new genomic techniques, even though it's an old technique, you know. But if it's related to grafted to genetically modified stock on the traditional conventional route, some people tend to think that it's a new technique. So this is a topic with a lot of uncertainties, legal and policy uncertainties, and regulatory uncertainties, and we are going to talk about that today. So I hope everybody's in and we can proceed with the slides. All right, so the structure is quite self-explanatory. We are going to talk about the importance of regulation, and not just in general, but also for scientists. And yes, definitions. I will cover some definitions, and gene technology regulations in different countries. So it will be Australia and other jurisdictions. So, well, why it's important? Well, if we speak about regulation of genetically modified organisms, the primary reason I would say is to regulate risks. And of course, there are other supplementary goals and aims of regulation. So we need to ensure that these risks are regulated within a well-defined and efficient framework that directed towards assessing and managing risks, ensuring compliance with regulation, and also making sure that for people like us, their clarity and they understand the priorities for further research and further improvement in this area. So the definitions of GMOs. Let's start with the Australian Gene Technology Act that defines GMO in different ways. So it's not just an organism that has been modified by gene technology. It can also be an organism that inherited particular traits from organism that occurred in initial organism because of gene technology, or it can be anything declared by the regulation to be a genetically modified organism. And this is where things are really complicated, because because what is technically genetic modification in a regulation may not be defined as a genetically modified organism. Yes. So there, which is not defined, which are not included in genetically modified organisms, a human being. So human beings is not covered by regulations. So there are different justifications for that, and legal and also, which I have not covered here, is some ethical reasons. And there are also international documents in this area, Cartagena Protocol to the Convention of Biological Diversity. They use a different term though. It's LMO, not GMO. So as I mentioned, there could be quite significant differences in approaches across jurisdiction or between international levels and national levels. So the Cartagena Protocol defines living modified organism as any living organism that possesses a novel combination of genetic material obtained through the use of modern biotechnology. So, and that's right, as I mentioned, they depend on jurisdiction. No, I don't think we will come in coming years. We will come to a point where we have a universal approaches, so universal understanding how to regulate GMOs, and the reasons for that are not just scientific; they are also policy reasons and reasons related to ethics, as I mentioned. And in public policy theory, on the regulation of GMO, we have an approach to jurisdictions through contrasting process versus product. To be honest, this is not a perfect approach, and I myself is not happy with some aspects of it, but that's how we approach it anyway. So process means that you basically regulate the process, and there are countries that approach this through the process point of view, such as the European Union or member states of the European Union, Australia and New Zealand, as a few examples. And product-based regulation is about the final product, that the outcome of genetic modification. So the process might not be that important. So classical examples would be the US and Canada of countries with product-based regulation. So Australia, as I mentioned, is a process-based regulation. There are few, there are quite several legal acts, but here's the basics. The main legal acts are Gene Technology Act and Gene Technology regulations. So they deal with procedures for licensing, certification, accreditation, monitoring, and enforcement, and so on. And Gene Technology Regulator and the Office of the Regulator are the main government bodies, or the regulator is the main government body dealing with these requirements and and procedures. Simply speaking, if you need a license for GMO if you're going to deal with GMOs in Australia, and the first step would be to go to Gene Technology Regulator with an application for a license. Here's a timeline. So we also, in addition to these two acts, we have intergovernmental Gene Technology Agreement. Of course, there are state and territorial legislation too. In Australia, that I think is quite exciting, is that the process is really straightforward. That makes it really efficient. So when you apply to the regulator, what they do is they start with a risk assessment and risk management plan. They also conduct consultations with the public, with different committees on different aspects of the application. And after that, they issue the licensing decision if all the requirements with legal compliance are in place. So there's a time frame for license decision. So if the basic application will take you only 90 days, if you don't intend to release a GMO into the environment, and of course, if it's more complex, if it involves a release into the environment, if there are risks which need to be controlled and managed and assessed, that might take longer, but not more than 255 days. And covering the topic of GMOs, I realized that GMO is very diverse, is a very diverse topic. We simply may not have time to talk about everything, all the complexities. And since I'm a lawyer with a legal background, we choose for our research topics which could be more not controversial, but more publicly or socially relevant. And when I speak about GMOs, we don't have many issues, social economic issues in applying GMOs in medical or pharmaceutical context. You know, like we have insulin, which is genetically modified, that doesn't cause any social, doesn't disturb any social or environmental groups. But if we speak about plants and food, well, that's a problem. And let's start with how GM crops grow in Australia. And as I said, the efficient and straightforward process in Australia is probably one of the reasons why Australia doesn't really have any, doesn't have many resistance or much resistance to growing GM crops. Of course, there are also economic reasons. And in Australia, GM crops grow almost everywhere, in every state. There are different histories in states and territories, how they approached GM crops. They were moratorious. And South Australia, for example, was the last state lifting the moratoria on GM crops in their state. So now it's only Tasmania that doesn't allow GM crops on their territory. South Australia allowed GM crops, but there's an exception, as you can see, in related to Kangaroo Island. You can't do this on Kangaroo Island, probably, I guess, for its relevance to tourism, or significance for tourism. And there are different genetic modifications subject to the regulation, and some of them are exempt. So you don't have to get a license for from gene technology regulator for any GMO. So there are some exemptions, and these exemptions are related to organisms that GMOs that assess as posing negligible risks, and also organisms that are GMOs but have been modified using methods and materials that are unlikely to result in novel combinations of genetic material. And well, everything else requires the license. So even but once again, as I mentioned, the process of licensing will depend on risks and other aspects of the process of the organism itself and the application. All right. So now we are coming closer to what in the title of this presentation was called CRISPR. Australia was one of the countries that excluded CRISPR, or more scientifically, or in other way, we can also say SDN1, site-directed nucleases type 1, from the scope of regulation. So there are certain conditions. It's excluded provided that there is no nucleic acid template added to cells to guide genome repair following site-directed nucleosification, and CRISPR generally falls within the scope of this condition. And there are no other traits from gene technology, no Cas9 transgene, no expressed protein. Yes. So I mentioned that there are different applications of GMOs in the context of pharmaceuticals, of foods, and there are different government bodies for that. So speaking about food, we also have Food Safety Agency, Food Safety Australia and New Zealand, that assesses the safety of genetically modified foods before they can be sold or used in Australia. And so the distribution of powers here is that the regulator issues the license. So still, once again, I will repeat that first step is the regulator. And after that, FSANZ, Food Safety Australia and New Zealand, they take over and they regulate foods using their competence. So they also have powers in labeling. So they identify needs for labeling genetically modified foods. So that's their powers. And there's also therapeutic goods administration. So if it's related to medicines, vaccines, you need also an approval from the Therapeutic Goods Administration. And if it's pesticides, animal medicines, and herbicides, all kind of things related to pesticides and veterinary medicines, for these applications and products, we have the Australian Pesticides and Veterinary Medicines Authority. All right. Just well, as once again, this is a topic which doesn't cover all the aspects of the regulation. So here is the list of different public authorities and agencies where you can find new information, additional information about how they approach, how they regulate GMOs. Now let me tell you about other approaches. As I said, there's no universal approach. Probably we'll never have any universal approach, which is quite reasonable. So yes, let me start with the USA, which is an example of product-based regulation, and they are quite interesting as a regulation because legally they don't even have such a term as GMO. So they approach it as genetic engineering, they approach it as intergeneric mechanism, and it's subject to environmental protection agency regulations under toxic substances control habits. So this is their approach is comparable to what I call a conventional genetic engineering because they primarily regulate into generic microorganisms as microorganisms or organisms that are formed by combining genetic material from organisms in different genera. That, simply speaking, it's transgenic organisms, and their regulation is quite relaxed. So they basically have reporting requirements. There are not so many harsh rules as I will later turn to European Union. So in the US, it's also the process is more streamlined and straightforward. So probably in a few months, as you can see in the slides, 10 days before a manufacture or import of intergeneric microorganisms or products out of this organism, you can get your approval in about 3 months. That's, as I said, that's the essence of the US approach, which is not very harsh, not very strict. And also, if you're trying to release, that would also require application approval by Environmental Protection Agency, and it's also not very strict. It's 60 days before the intended field use. Now, European Union, well, this in the literature, it's called one of the strictest approach, or it's probably the most strict approach in the world. So the European Union rules on GMOs, well, are quite different from other jurisdictions in a way that they have specific regulations for release and specific regulations for genetically modified food, and also separate regulation for the contained use of genetically modified organisms. And here's you can see I've conducted some comparison between risk analysis conducted in the EU and Australia. And if you look into Australia, you can, well, the difference is obvious because, as I mentioned, in Australia, process is more straightforward, and there are not so many stages in this process. And the similarity here is that in Australia, states and territories, they have the right to impose GM moratoria. And in Europe, it's similar, that member states of the European Union can also adopt moratoria, even though it's called opt-out measures. So they can opt out from growing GMOs on their territory. And this opt-out from growing GMOs is, well, it's probably everywhere, except for a few countries like Spain and Portugal, which still grow GMOs. Although I really doubt that people from Spain and Portugal are even aware of that, because the amount of it's only MON 810 maize, and the amounts are really negligible. So the trends of growing GMOs in Europe is that the GM crops in Europe are going down, and probably in the future there will no GMO grown in Europe. In particular, as I see it, and I think it's quite obvious from the process, is that because, well, there is a lot of bureaucracy. So, and every application in Europe requires a lot of resources, a lot of effort, and a lot of time without the guarantee that your investment will not go to waste, because that happens quite often in Europe. And this is a simplified comparison, and in a very simple form. Here's the more detailed description of the process in Europe. This process deserves to be expounded or explained probably for another hour or more. We don't have that much time, so you can just look at this slide and you can see how difficult it is and how complex it is. There are so many agencies and bodies involved in this. In Australia, the process starts with gene technology regulator. Office of Gene Technology Regulator supports the regulator, and to get the license, you don't have to engage with other government bodies and agencies. Here it's a different situation. Every member state has a voice. Every member state has the power to basically not to block, but at least to impede the application towards the final authorization. It's also a difference between EU and Australia. In Australia, it's called licensing. In Australia, authorization. Basically, that's the same result. And as I said, there's a significant opposition to genetically modified organisms in Europe. And the decision-making in Europe has a lot to do with that, because every member state has the vote, but to take the decision in Europe, you need to go through the process of qualified majority. And the qualified majority voting system is also complex. It's not just simple majority, as it means that 55% of member states, which are 27 now in European Union, need representing at least 65% of EU population need to vote. And that never happened, by the way. So whenever a GMO application for a authorization of GMOs goes through this process in Europe, this voting never accepts GMOs in Europe. So after that, the process goes towards the back loops again to member states, to European Commission, and appeal committee. There are appeal committees, different. There are also other committees which you can create in case if you have any doubts. So it might take years. Sometimes a GMO approval takes more than 5 years. It's a very long process. So that's an explanation. Although, as I said, with all those differences, the European Union still manages to process this application. So we have almost the same, more than 100, almost the same as in Australia. So more than 100 events approved in the European Union, genetically modified events, and more than 100 events approved in Australia. And I think since we have the advancement, the technological advancement and genome editing, we will probably have numbers grow in the future, in coming years. And now we have, I have to cover also economic background of economic realities of GMOs. So whatever happens on the regulatory level, however the countries or jurisdictions approach GMOs, we need to face the fact that when it comes to cash crops, well, most of them are GMOs. So in the situation of food industry, we have a need, if it's a meat industry, for example, and when it comes to feed for cattle, European Union faces a very tricky situation when they basically, in fact, they ban GMOs and still they rely on imports. And they import a lot of soybean, for example, as feed, and it comes from countries which are mainly producers of genetically modified crops, like USA, which is the largest producer, and Brazil, Argentina, Canada. So, as you can see, Australia here is number 13. So it's not the major producer. In Australia, it's three genetically modified crops: cotton, canola, and safflower. Sorry for the spelling mistake here. Right. And by the way, almost 100% of Australian cotton is genetically modified. So there's a high chance that if you see a proud label that says Australian grown cotton, this probably will be, most probably will be genetically modified. And also social reasons. So we covered economic reasons. So these are really tricky situation when we have dependency on GMOs on a global scale, if you want. And countries have to approach that in different ways by growing GMOs like the US and exporting that, or by relying on importing GMOs. European Union and United States, they are really rivals in this area because they had issues in World Trade Organizations. US sued European Union for what they perceived were trade barriers because they didn't want to allow GM crops growing on the territory of the European Union. And it seems that, well, but even though they are rivals, they highly depend on each other, I would say. And social reasons. We have also a very harsh, very controversial history of public opinion, public perception about GMOs. Not in Australia, by the way, in Europe. And in Europe, there were even violent protests against GMOs. So there were organizations and people destroying crops, and some of them even got criminal. They were held liable, criminally liable for what they did. But that's what happened in the EU. So that's also the historical preconditions and undescended events like mad cow disease, for example. That's also an event that affected the public perception of risks, and that might be explanatory why public perceives risks in this particular way. But when it comes to analyzing what really concerns people, there are different polls, different surveys. And the last one, this 2019, we don't have fresh data from Europe, but Europe is the obvious cause for comparison because of these controversies which I described, and socially what was perceived socially, the social approach was very confrontational. But when it comes to what we tell CRISPR is, because it's part of genome editing, really we see that, well, it doesn't really bother people that much. So if you look into the numbers, you can see down over there below genome editing. So only 4% of EU respondents identify genome editing as a most concerned food topic for them. So for them, there's plenty of other concerns, and we can see the trend in more social tolerance or social acceptance of new technique of genome editing in industries and in crops and plants and foods, right? And so as I mentioned before, Australia in 2019 excluded SDN1 type 1 techniques, directed nucleases type 1 techniques from the scope of regulations. Europe is trying to do the same. So in 2023, the European Commission issued the proposal, a proposal for a regulation for plants that are developed through new genomic techniques. And under this proposal, which is similar to what Australia has done, plants that contain genetic material from the same or crossable plant can occur naturally or via traditional breeding, will be subject to simpler regulations. And here is interesting case of the United Kingdom, because the United Kingdom, as we know, used to be a member of the European Union. And after they left, they adopted UK Genetic Technology Act, because now they have more power to adopt their own regulations without the need to harmonize that with the European Union. So in March 2023, they passed a new regulation which basically implemented the rules that the European Union is trying to adopt. It doesn't apply to Scotland and Wales, though. Only England. So that's an interesting example. So UK is not just distancing itself from the European Union politically, but also economically, regulatory. And this is evident in the case of GMO regulations. So in this respect, UK is probably trying to revive itself as part of the Anglo-Saxon world, trying to be more similar to other countries like Australia, like Canada. And yes, here is the outline of other countries. And we have European Union here in red, as I mentioned, with the regulation of new genomic techniques, including CRISPR, will be regulated as GMOs. So we need to take into account that there is a proposal, but we need to realize that this proposal, we don't really know how they are going to adopt that, because this proposal now is endorsed by the European Parliament, by the way, but now it goes to the member states, and the member states are in the main opposition to GMOs and NGT including. If we look into other red countries, there's the interesting case of New Zealand. They don't allow GMOs in GM crops there. Mexico, yeah, and I think more that's about it. So countries like Australia and England, as I mentioned, who are excluded new gene technologies like certain techniques of genome editing from the scope of their regulation are not alone, and they are not the first ones. South America is the pioneering countries here. If you look into South America, almost all major economic players on the market adopted the regulations, excluding genome editing, certain techniques of genome editing from the scope of the regulation in a way similar to the amendments I've described below. Argentina was the first one in 2015. And after Argentina took this step, other countries followed. Chile, Brazil, Colombia, they adopted the same approach. India, too. The case of the US, as I explained before, is a different case because they only regulate transgenic GMOs, and Japan, quite interestingly, followed the same approach. And Canada stands out because they basically regulate novel traits, novel foods, or novel crops, regardless of techniques used. So as I mentioned before about the product-based regulation, so if we use this regulatory standard or approach in Canada as an example of plant-based regulation, that's probably the purest, if you can say so, case of plant-based regulation. So they don't regulate process as such. There are gray areas, so many of them, most of the world, the gray areas. That's in many other countries for reasons are different. So quite common reason is that many countries don't even have the technical capacity to identify GMOs. Without the technical capacity to identify GMOs, they don't have means to control the importation. They can't really control the occurrence of GM or on their territories. So there are technical reasons. So there are also, once again, ethical reasons, social reasons. So you can't say that this one approach suits all, but the most of the world, and you can see it's on the map, they don't really have clearly defined approach to how to regulate CRISPR. And I would like to acknowledge Pratap Devarapalli and Brett Sherman from the School of Law, who also participated in preparing these slides. And that's it. Yes, I'll be happy to answer your questions, please. Yes. So no questions, though, I understand. Because I don't, yes, now we can, yeah. Thanks. Thank you for coming.